Hello everyone, welcome to our YouTube channel R Square Pathshala. My name is Ravi Sani. In the previous video, we have discussed about latitude and longitudes. We learned about how to locate a place on the globe using latitude and longitudes, and also how to determine a time of a place on the globe. So in this lecture, we will be discussing about motions of the earth. So let's start. As we all know, earth has two types of motion. One is rotation and other is revolution. Okay. Rotation is the movement of earth about its own axis. Okay. And the movement around the sun in a fixed path or orbit is called revolution. See, this is the earth. This is imaginary line. Okay, the line joining north and south pole. This is the axis of the earth. Now the movement of earth around this axis, like this, from this symbol we can see earth moves from west to east. So about this axis there is a movement of earth, that is called rotation, and the movement of earth around the sun, one is about its own axis, that is called rotation, and the one movement is around the sun, that is called revolution. Let me show you in this figure. This is our sun. This earth moves about its own axis, that is rotation, and one earth moves like this in this path, that is revolution. This is sun. Okay, the axis of the earth, which is an imaginary line, as already told, this is an imaginary line. This line makes an angle of 66.5 degree with its orbital plane. Okay, orbital plane, this is earth orbit. Okay, this is earth orbit, and from this orbit, this angle, this is 66.5 degree. Okay, this is imaginary line or axis of the earth. This line makes an angle of 66.5 degree with the orbital plane. Okay, the plane formed by orbit is known as orbital plane. This is orbit, and this plane formed by this orbit is orbital plane. Okay, the earth receives light from the sun. Due to the spherical shape of the earth, only half of it gets light from the sun at a time. Okay, see, this is our sun, this is earth. Earth is a sphere. Okay, at any point of time, only half of the earth will be facing the sun, and half will be in the dark. So the portion facing the sun experiences day, while the other half away from the sun experiences night. Now this yellow part is facing the sun, so here is day. The part of the earth behind this part, so this part is facing night. So the circle that divides the day from night on the globe is called circle of illumination. So this circle, this is the line, which divides the earth into two parts, and this line, imaginary line, is known as circle of illumination. On one side of this circle of illumination there will be day, on the other side there will be night. The circle does not coincide with the axis, as you see in figure 3.2. see, this is our axis of the earth. Okay, this is axis of the earth about which earth moves. Now the circle of illumination is in this vertical direction or in vertical plane. So earth takes about 24 hours to complete one rotation around its axis. Earth rotates from west to east around its axis in 24 hours. Okay, so the period of rotation is known as earth day. Period of rotation is 24 hours. In 24 hours earth completes its one rotation. This 24 hour is earth day. So this is the daily motion of the earth. Okay, so in other figure we can see this is the orbital plane of the earth. So this is imaginary line making 66.5 degree angle. Okay, about Tropic of Cancer, Equator, Tropic of Capricorn, Arctic Circle, Antarctic Circle we have learned in the previous lecture. You may go to the previous lecture if you have not clear about it. Okay, so next, so now just assume as we have learned, earth is rotating about its own axis. Earth is one movement is rotation. So assume, what would happen if earth did not rotate. So the portion which is facing the earth would always experience day, and thus bringing continuous warmth to the region. The other half would remain in darkness and be frozen cold all the time. So when earth do not rotate, the face of the earth facing the sun, the portion of the earth facing the sun, there will be warmth always, and the one which is in the dark side will be cool always. So in that scenario, life would not have been possible in such extreme conditions. Okay, so the second motion of earth around the sun is orbit, is revolution. Means the second motion of earth, one is rotation we have discussed, the second is rotation. Rotation is the movement of earth in its orbit around the sun. So this is earth, this is earth's orbit, earth is moving in this direction around the sun. So this is a revolution. Okay, earth takes 26 365 into 1 by 4 days, means 365 days and 6 hours to complete one revolution around the sun. So we consider this period as year. Generally we take 365 days a year only and ignore 6 hours for the sake of convenience. So these 6 hours saved every year are added to make one day, that is 24 hour over a period of 4 years. So we consider a year of 365 days only. The extra 6 days we count in the fourth day, in the fourth year, sorry, in the fourth year. In the fourth year, 6 plus 6 plus 6 plus 6 makes the 24 hours, and one extra day is added in the month of February. So in every fourth year, February has 29 days instead of 28 days. So in that year, the year will be of 366 days, and that year is called leap year. Okay, leap year comes after every 4 years. In the leap year, the number of days is 366 instead of a normal year having days 365. Okay, so from this figure 3.3 we can uh, clearly see the earth is going around the sun in an elliptical path. So this path is not circular, it is elliptical. Okay, so throughout its orbit, the earth is inclined in the same direction. See here, if we assume the position of earth is here, earth is inclined like this. Here also earth is inclined like this. From this angle 66, this angle is also 66. So this again same angle, this again same angle. So earth is inclined in the same direction. A year is usually divided into summer, winter, spring and autumn season. So season change due to change in the position of the earth around the sun. So this is important here. The length of day depends on the rotation of the earth, and season changes due to the revolution or due to the position of earth around the sun. Okay, so in the 21st June, on the 21st June, the northern hemisphere is tilted towards the sun. So if we see in this figure, this is 21st June and this northern hemisphere is tilted towards the sun. Okay, the rays of the sun fall directly on the Tropic of Cancer. So this is a Tropic of Cancer. here the sun rays falls directly on the Tropic of Cancer. So as a result, these areas receive more heat because sun is directly above the Tropic of Cancer. The area near the poles receive less heat as the rays of the sun are slanting. So over these areas, the rays of the sun are not above the poles. Okay, so the north pole is inclined towards the sun. As we can see from the figure, this is north pole and this is inclined towards the sun. And the places beyond the Arctic Circle experiences continuous daylight for about 6 months, because this part this part is continuously receiving lights of the sun. So we can say this area beyond Arctic Circle experience continuous daylight about for 6 months. Since a large portion of the northern hemisphere is getting light from the sun, it is summer in the region north of the equator. The longest day and the shortest night at these places occur on 21st June. So above this equator, above the equator, northern area, here the maximum the longest day and the shortest night at all these places above the equator will occur on 21st June. Okay, at the same time in the southern hemisphere all these conditions are reversed. In the southern hemisphere here all these conditions are reversed. Okay, in it is winter season in the southern hemisphere. The nights are longer than the days. The position of the earth is called as summer solstice. So this position is known as summer solstice when uh, there is summer in the northern hemisphere and the winter in the southern hemisphere. Summer solstice is summer in the northern hemisphere and winter in the southern hemisphere. Okay, similarly if we take the position of earth opposite to this summer solstice, this position on 22nd December. So on 22nd December the Tropic of Capricorn receives direct rays of the sun as the south pole tilts towards it. So case is opposite of summer solstice. Here the south pole is tilted towards the sun. So the sun is directly above the Tropic of Capricorn. So as the sun rays fall vertically on the Tropic of Capricorn, which is 23.5 degrees south, a large portion of the southern hemisphere gets light. Therefore, it is summer in the southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. The position of earth is called winter solstice. So this solstice here, the northern part is having summer, so it is this position of earth is summer solstice. Here our northern hemisphere is feeling winter. The season is winter, so we call it as winter solstice, which is winter in the northern hemisphere and the summer in the southern hemisphere, which is reverse of summer solstice. Okay, so from this we can easily say that Christmas in Australia is celebrated in summer season. Okay, because if in this position there will be summer in the southern hemisphere and Australia lies in the southern hemisphere. Okay, so on 21st March and September 23, direct rays of the sun fall on the equator. We are talking about this position and this position. Okay, the rays of the sun fall on the equator. So at this position neither of the poles is tilted towards the sun, as we can see from the figure. Neither of the pole is tilted towards the sun. Okay, so the whole Earth experience equal days and equal nights because the poles are not tilted towards the sun. So whole Earth experience equal days and equal nights. These positions are called equinoxes. So this is equinox where days and night are equal. Equinox. Okay. So on 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st March when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus, you find that there are days and nights and changes in season because of the rotation and revolution of Earth respectively. So, there is days and nights because of rotation, and there's changes in season because of Earth revolution. Okay, so in the figure, if we see on the 21st March, there is spring in the northern hemisphere and winter in the spring in the northern hemisphere and autumn in the southern hemisphere. And on 23rd September, autumn in the northern hemisphere and spring in the southern hemisphere. Okay, so in this chapter basically we have learnt about the motions of the earth. One is rotation and other is revolution. One is about its own axis, which is an imaginary line, and that imaginary line is tilted, imagine having an angle of 66.5 degree with its orbital plane. Then we have seen the summer solstice, that is on 21st June when the northern pole is tilted towards the sun. Then we have seen, we have learnt about winter solstice where southern pole is tilted towards the sun. Then we have seen the position of earth called equinoxes. Then we have learnt about leap year, elliptical orbit. Okay, so that's all in this chapter. Try to solve this question given at the end of the chapter. If you have any question, please post me on the comment section. Thank you very much.